All right, welcome back. So, we've talked about the essentials of cloud security before, but today we're taking it to the next level. We're not just locking the doors anymore. No, today we're going to build a full on fortress. We are diving deep into the world of identity and security in the cloud. And that really is the central question, isn't it? It's the big challenge of cloud security. We don't have physical walls or moats to protect us. Our entire kingdom, all of our data, our applications, our services, it all exists in this abstract thing we call the cloud. So how in the world do we protect it? Well, we build a digital fortress. So for the next few minutes, I want you to think of us as architects. But our building materials aren't stone and mortar. Nope. Our building materials are things like identity and access management, virtual private clouds, and encryption keys. Together, right now, we're going to draw the blueprint for a truly secure cloud environment. Now, our blueprint has four main parts. First, we'll build the outer walls. That's all about securing the perimeter. Then, we'll post the gatekeepers, managing who gets in and what they can do. After that, we got to protect the crown jewels themselves with some serious encryption. And finally, we'll pull it all together and review the whole plan. Every good fortress needs strong walls. And in the cloud, this perimeter really does two big things. The first, is fending off the obvious stuff. Those big external attacks, like a denial of service attack that tries to fledge you offline, that's a job for a service like Cloud Armor. But the second job, and honestly the trickier one, is defining a boundary to keep your valuable stuff inside. And that's our first line of defense. But here's where it gets really interesting. The biggest threat might not be some hacker in a dark room. It could be one of your own employees, someone with totally legitimate access who, maybe accidentally or maybe not, tries to copy sensitive company data out of your secure network. How do you even begin to stop that? The answer is this really cool tool called VPC service controls. Honestly, the best way to picture it is like an invisible fence for your data. It doesn't matter if you have the keys to the castle. If you try to walk out the front gate carrying company secrets, this invisible fence just blocks you. Simple as that. And setting up this fence is surprisingly simple. First, you just draw the boundary. You group all the projects you need to protect into what's called a perimeter. Then, second, you create an access level. That's just where you define the rules for getting in. Like, hey, only people connecting from our corporate office's IP address can even get near this stuff. So here's why this is absolutely crucial. Let's say you have a data analyst. They have the right permissions to query a super sensitive data set in BigQuery. But with VPC service controls in place, you can physically stop them from exporting that data to, say, their own personal cloud storage bucket, or worse, trying to attach it to an email. This is how we build real walls in the cloud. Okay, our walls are up. They're strong. Now it's time to manage the gates. Who are we letting inside? And what exactly are they allowed to do once they're in? This is the whole world of identity and access management, or as you'll hear it all the time, IAM. Now, in Google Cloud, permissions are all structured like a kingdom. It's a hierarchy. At the very top, you have the organization. That's the entire realm. Under that, you can create folders, which are kind of like separate castles for each department, one for finance, one for engineering, and so on. Then, inside those folders, you have projects. Those are the individual rooms. And the key thing to get is that permissions are inherited. They flow down. If you have access to the finance castle, you automatically get those permissions in every single room inside it. The policies just add up as you go down the chain. So, where do these user identities actually live? Well, traditionally, companies managed all this stuff themselves in an on-premises system, probably Microsoft's Active Directory. But for the newer companies, the ones that were born in the cloud, they often use a service like Cloud Identity, which manages everything online from the get-go. But this brings up a huge, very common question, right? A big company isn't just going to throw away decades of user management and infrastructure just because they're moving to the cloud. They need their employees to use their existing corporate login to get into all these new cloud resources. So how do we connect the old kingdom to the new one? The solution has a fancy name, Identity Federation, but the idea is pretty simple. It's basically a diplomatic agreement between two kingdoms. Your cloud environment agrees to trust the identities managed by your company's on-premises Active Directory. So when an employee tries to log in, Google Cloud just redirects them to their familiar corporate login page. They sign in there, and they're in. It's this beautiful, seamless way to let your allies into the gate using the keys they already have. Okay, we've got strong walls, we've got trusted gatekeepers. But what happens if a really clever thief gets past both of them? This is our final layer of defense. It's all about protecting the treasure itself. And that's where we need to talk about encryption.
I love this quote because it gets to the absolute heart of the matter. You have to assume that even with the best walls and guards, a breach is always possible. So if a thief does manage to get into the vault, we need to make sure that all they find are a bunch of locked treasure chests that they have absolutely no way of opening. Now, to lock those treasure chests, you need keys. And to manage all those keys securely, you need a master keymaker. In the cloud, that's the Cloud Key Management Service, or KMS. It's this central, secure place to create your keys, use them, rotate them on a schedule, and, when the time comes, destroy them for good. So let's get into a specific scenario. Let's say your company has a really strict compliance rule. Maybe you do work for the government or you're in finance. You have to meet this high security standard called FIPS 140-2 Level 3. And what that basically means is you need a dedicated, physical piece of hardware to protect your encryption keys. But you don't want to buy and manage that hardware yourself. What do? This brings us to a really important choice you have inside Cloud KMS. For most things, you'll use the standard software-backed keys. They're incredibly secure. But for those really high compliance situations, you need to bring out the big guns. You need a Cloud HSM, which stands for Hardware Security Module. This means your keys are generated and stored inside a dedicated physical tamper-resistant chip. It gives you the absolute highest level of security assurance, all while being managed as a service by Google. It's really the difference between a very strong digital lock and a physical unpickable bank vault.
All right, we have designed our entire digital fortress. We've put up the walls, we've posted the guards, and we have secured the vault. Let's take a step back and just look at the complete blueprint we've made. And this table just sums it all up perfectly. To stop data from walking out the door, we built our digital walls with VPC service controls. To manage who can do what, we established the kingdom's laws using the IAM hierarchy and folders. To connect our existing login systems, we brought in our allied gatekeepers using Identity Federation. And for that ultimate, final layer of security, we built an unbreakable vault using Cloud KMS, backed by those hardware security modules. So, our fortress is built. It's strong, it's layered, it's secure. But here's a final thought to leave you with. The really big philosophy in security today is this idea of zero trust, which basically assumes there is no trusted network. There is no safe perimeter. So in a world like that, is the whole idea of a fortress outdated? Maybe the future isn't about building better and better walls, but about learning how to live securely without any walls at all. We'll have to explore that one next time.